right, welcome back to Astronomy in the News. AoTATX number 21. I'm Astro Boz.
I am Astrobit. Welcome back. Okay, so starting out, we're starting here on Earth. Construction is complete on the largest radio telescope in the world. Sorry. Built in China's Guangzhou province. Hopefully I'm saying that correctly. The antenna spans 1,650 feet across. It's 65% larger and 2.5 times as sensitive as the previous record holder, the Arecibo radio telescope in Puerto Rico. It's constructed of over 4,000 individual panels. You can see one of those in the picture on the upper right. It's about to go into a testing phase now that the construction is complete, after which it will be used internationally to observe the structure of the universe as well as to search for aliens. There was a little bit of controversy when it was built. There was a village of 65 people who were located right underneath the middle of the telescope there in the... they weren't too happy about being moved, but they were moved in 2009. Chinese media reports that they now enjoy better living standards, and the villagers in the nearby communities think they're very lucky and that they should thank the aliens for the improvement in their life.
Okay, the code that brought the astronauts to the moon on the Apollo 11 mission is now available for everybody to see on the internet. The entire printed code is shown here. When stacked up as tall as Margaret Hamilton, who was the lead software or the director of software engineering for the project. She actually coined the term software engineering. It didn't exist before she invented it. This entire stack adds up to only 3.5 megabytes of text, which is incredible. It's someone went through and wrote every line of code in this stack, and it's now available on GitHub. You can go download this code because someone went through the hard work of writing everything down and putting it into modern programming languages, or at least it's available on the internet. It's full of interesting, fun things. You can see a few here, as in, this is an instruction to the astronaut telling them to please crank the silly thing around. So, my favorite was temporary, I hope so, I hope so, I hope so. That was in the code. It turned out to be permanent. So, yeah, and it's possibly fake. That's right. Thank you.
All right. Last month, NASA released a spectacular series of images. Yes, here it comes. Of the minor planet Ceres. This Dawn spacecraft has been out studying for the last year. The video here that you see was created from the Dawn mission team. It simulates the appearance of the planet based on all the thousands of images and gigabytes of data that have been sent back from the spacecraft. In this video, the surface features have been enhanced by a factor of 2 just to make them a little bit more visible. What you're seeing is essentially a simulation or a model of the planet constructed from those images. Dawn's primary mission ended on June 30th, but it will remain in Ceres and continue working until at least 2017. What's going to happen to it after that is yet to be determined.
All right, so astronomers have been studying the data that came back from Dawn, studying Ceres, and you notice that there are many bright spots. So Maria Cristina de Sanctis from the National Institute of Astrophysics in Rome has led a team to study what is causing these bright spots. The leading theory before this was something similar to Epsom salts that you'd put that we have here on Earth. But it turns out that her team proved that it was sodium carbonate. On Earth, this is the material that's typically found in hot springs or from evaporating lakes. So what this tells us is that at some point in the past, Ceres had water beneath its surface. And this is similar to phenomena that we see in one of the moons of Saturn, Enceladus, that is ejecting large amounts of water and sodium carbonate into space through these large geysers that are escaping from the moon. Rumor has it that Sandals is going to be preparing for an AoTATX crater hot springs at its resort.
All right, Jupiter put on a great fireworks show for the arrival of the Juno spacecraft on the 4th of July. What you see here, observed by the Hubble Space Telescope in the ultraviolet, these are Aurora on the north pole of Jupiter. It's 100 times stronger than the Aurora that we have here on Earth. They're created by a combination of the solar winds, which is what caused the aurora on Earth, as well as interaction between Jupiter and its moon Io. Jupiter's strong magnetic field means the aurora is actually continuously occurring on this planet. Unfortunately, it is not visible to the naked eye.
So you need Hubble. So this is the Juno spacecraft that recently arrived at Jupiter on the 4th of July. You can see the orbit of Juno after it left Earth. It left Earth on 2011 and then got there just recently. So after traveling for over 5 years, or right around 5 years, it reached its destination of Jupiter. You'll notice that in this orbit, you got a gravity assist from Earth, and it also used ion thrusters that were powered from the solar wind only to get there. So a little gravitational assist from Earth and then ion thrusters. Juno is going to study the composition and temperature of Jupiter's atmosphere, and it's also going to study the magnetic field and the auroras that you just saw in that beautiful last image. At the end of its mission, it's going to plunge into Jupiter in 2018, and that's to keep it from contaminating the moons of Jupiter with contaminants that are on it from Earth. There is no comment yet from people living on Jupiter as to how they feel about this.
All right, first of its kind planet has been found orbiting a triple star system. So Kevin Wagner, a first-year graduate student at the University of Arizona, discovered this. He used direct imaging, so he actually imaged this planet. You can actually, there's a picture. It's really poor quality, so I didn't include it here. But there's a picture that shows this planet. What we have here on the right side are two stars, B and C, in the system that are orbiting one another. Then there's the bright star on the left called A. Those three stars are all orbiting one another. And then the planet, kind of shown here with a reddish orbit, is orbiting just the A star in the system. We did not expect to find any systems like this. This is an extremely unstable type system, so it's very surprising to have discovered any one of these. This section of the sky that this was found in the constellation Centaurus, is also studied by one of our own UT astronomers, Adam Krause, who you may also know as Captain AO.
The first water clouds outside of our solar system have been found on a brown dwarf by the Gemini telescope in Hawaii. This is an artist's rendering of that brown dwarf. The brown dwarf is 7.5 light years away. So astronomers have found water clouds on a brown dwarf 7.5 light years away. This is, brown dwarfs are a little bit larger than planets, but smaller than stars. So this is about a mass of 3 to 10 times the size of Jupiter. The temperature of this brown dwarf is about 10 degrees Fahrenheit. So we can conclusively say that Austin is not on a brown dwarf.
All right, moving a little bit further out in the universe, Alexander Kalinsky has proposed that dark matter may consist of 30 solar mass black holes that were formed within the first 300 million years after the Big Bang. So these black holes would have formed the normal way by which we consider black holes to form, which is gas forms a star, and then eventually, for a massive star, it burns out and collapses down into a black hole. Instead, these were formed very, very, very early in the universe and may have involved some exotic forms of matter that formed early on in the universe, where it's still unclear exactly how this may have happened. What we see here on the top right, well, on the left is a picture of Alexander Kalinsky and an unexplained frog thing. On the top right is a star field that's taken in the infrared. The bottom picture is the same image with all of these stars subtracted from it. And what you see in the background is a kind of background glow of the universe. The clumps that you see here would be naturally explained by 30 solar mass black holes. Now, the reason that I say 30 solar mass, this is very important. LIGO just discovered 30 solar mass black holes merging a little over a year ago. We do not really know why black holes of this mass exist. We were actually a little bit surprised that they found black holes of this size. So it's very exciting that this may naturally explain LIGO's results.
Okay, and our last Astronomy in the News story of the day. A paper in May came out, and it's notable because it was written by Stephen Hawking, Malcolm Perry, and Andrew Strominger, that proposes the idea that black holes are not bald, like some Astronomy on Tap MCs, but instead actually have some soft hair surrounding them. And this possibly solves the information paradox of black holes, where instead of matter falling into black holes and the information of what fell in is lost forever, there's possible that the quantum fluctuations around the black hole, which is really roughly drawn in this picture, quantum fluctuations around that black hole contain some of that information of what fell in, and those quantum fluctuations are referred to as soft hair. This is not the first paper that proposed soft hair, and it's still a very controversial idea. It gets a lot of attention based on who the authors are, but they have also really firmly believed that this is possibly leading to the solution of the information paradox. LIGO is going to give us more information on this event, and will give us final confirmation, hopefully, whether this is actually a property of black holes or not. Bald black holes, I should say, are black holes that are only determined by their charge, their mass, and their spin. Very simple. That's it. That's all you can say about a black hole. Instead, this tells you that there's maybe some more information out there as to exactly how that black hole formed and what it is. All right.
All right, that's it for Astronomy in the News. I'd like to thank Brandon. I'd also like to introduce and thank you. I'd like to thank MCXO. She is going to be taking over, or not taking over, but assisting me, taking over Brandon's role starting next month. She assisted in building up the slides this month. So look forward to MCXO joining us next month. Thank you.